Hi class, we're just continuing our gas law videos. This is the second one, really. It's just the example problems from the first page, which is Boyle's law. So I want to finish these up. I'm actually going to switch pen colors just because I think it's easier to see the difference between the two problems. So it says 5.00 liters of a gas is at 1.08 atmospheres. What pressure is obtained when the volume is changed to 10.0 liters? So we're going to box our data. 5.0 liters, 1.08 atm, that's atmospheres. And I want to underline my question. So that's what pressure is obtained. And then it says the volume is changed. So volume is changed. That means that this is going to be my second volume, 10.0 liters. Okay. And so I have volume, I have pressure. I have two values of each. P1, V1, P2, V2. My initial pressure is 1.08 atm. 1.08 atmospheres. My original volume is 5.00 liters. And P2, that's what I'm looking for. So I'm going to put a question mark to just kind of hold my place. And then V2 is changed to 10.0 liters. So 10.0 liters. Okay. It might be a good idea. I didn't do this on the last problem, but it might be helpful right at this point to look at your pressure units and go ahead and write this down. This is atm. It's going to be atm because that's what's given in the original problem. So I know my answer is going to come out in atmospheres. All right, we go to solve the problem. We're going to plug in these variables to the equation, which is written above. P1 times V1 equals P2 times V2. So that's P1 V1 equals P2 V2. Remember, this is multiplication, not addition. Okay, so I have 1.08 times 5.00 equals, P2 is unknown, so I'm just going to leave it as P2, and then 10.0 liters. 10.0. Okay, so if I multiply 1.08 times 5.00, I'm going to get 5.40 equals, I can't simplify this anymore, it's just 10.0 times P2, so 10.0 P2. All right, so I have 5.40 and I have 10.0 P2. I want to get P2 by itself, just like if you were solving for X. I want to get this by itself. To do that, I've got to divide by this number. Divide it here, you got to divide it here. So P2 equals 5.40 divided by 10.0. 5.40 over 10.0. And you get 0.540. 0.540. Again, our units here are atmospheres, so we'll write atm. Kind of wrote that small, but hopefully you can see that. P2 is 0.540 atmospheres for our second problem. Switching back to green, let's wrap up this third problem. Example number 3. 2.50 liters of a gas was at an unknown pressure. Sounds like a key term. I'm going to circle it. It's an unknown pressure. However, at standard pressure, that is a key term. We know that standard pressure, as we mentioned before, standard pressure is 1 atmosphere. I'm going to put 1.00 because we usually want at least 3 sig figs. It's sloppy, but that's atmospheres. Okay, its volume was measured to be 8.00 liters. What was the unknown pressure? That's my question. What was the unknown pressure? Well, the unknown pressure was when I had 2.50 liters. So that sounds like my first pressure. I'm going to write this down. P1, V1, P2, V2. All right. So my unknown pressure, I'm going to say that's my first pressure. My volume at the unknown pressure was 2.50 liters. However, at standard pressure, again, that standard pressure is 1.00 atm. V2, what was the unknown volume or unknown pressure? That's our unknown. At standard pressure, its volume was measured to be 8.00 liters. Right, and I'm, again, looking for pressure. I'm going to give it in atmospheres. You could solve this several different ways. You're going to get a different answer if you solve it in millimeters of mercury or in kilopascals. You'll get different numerical answers. But in this problem, it just says, what was the unknown pressure? It doesn't tell you what units you need to use. And because of that, I'm just going to use the units that are easiest for me. And since I know that standard pressure, right here, standard pressure is 1 atmosphere, I'm going to leave it in atmospheres because that's easier than converting it to millimeters of mercury or kilopascals. But you could certainly do that. It's just an unneeded step, and you're just going to get a different number and also different units. All right. Go ahead and set up our equation. P1 is our unknown, so I'm just going to call it P1 times V1, 2.50. Again, I'm using this equation. P1 V1 equals P2 V2. I didn't write it out here, but that's the concept. P1 is 2.50, or P1 times 2.50 equals 1.00 times 8.00. And you can see that the math here is not going to be very hard. I have 2.50 P2, or P1, sorry. 2.50 times P1 equals, and then 1.00 times 8.00, that's just 8.00. Anything times 1 is just the same number it was before. And now I want to solve for P1. Just like if it's x, I need to divide by whatever it's being multiplied by, so it'll be by itself. If I divide here, I got to divide there. So P1 equals 8.00 divided by 2.50. If you do that in the calculator, P1 equals 3.20 atmospheres, ATM. All right, and just in case you decided to solve this in terms of kilopascals, the answer in kilopascals should be something like 324 kilopascals. So I could say or 324 kilopascals. Of course, this number would be different. That would be 101.3, and you're going to get a final answer of somewhere around 324 kilopascals. And if you were trying to solve it for millimeters of mercury, you should get something like 2,430. So those are your 3 answers. If you solved it like we did here in atmospheres, that's your answer. If you chose to use kilopascals, that number would be 101.3, and this would be your final answer. And if you wanted to use millimeters of mercury, this would be 760.0. this would be your final answer. This is, of course, rounding to 3 sig figs in each case. I hope that's helpful. These are just the example problems for Boyle's law. Next video, we're going to talk about a new one. We're going to talk about Charles' law.